the case control study design. The case control study design was originally sort of conceptualized in the famous event with the Broad Street pump out of London. In the Broad Street pump incident, John Snow identified the fact that a common characteristic among those dying from this cholera infection in London all had that same characteristic, that they, or at least almost all of them had the characteristic that they lived very close to this particular pump. And this is the underlying thinking of a case control study, that instead of looking at what happens to users of this drug and that drug, we see is there some characteristic that is more common among those with the disease, here dying from cholera, to identify risk factors for death. The classical case in which we usually sort of ascribe the case control design to is the event of smoking and lung cancer, or the association between smoking and lung cancer. And the earliest example I've been able to find is this one, where they compared the smoking patterns among 86 cancer patients, and in this case 3 of them were non-smokers, and they identified individuals without cancer and identified 14 non-smokers. This is a fairly old study, which is also the reason why the vast majority of all adult males were in this particular setting smokers. So this is sort of the association version of also including the background population. With the Broad Street pump, it was so evident that almost everyone had this particular defining characteristic of having used this pump. But with highly prevalent conditions or exposures such as smoking, we need to contrast the sort of proportion of having this characteristic to the likelihood of having this characteristic in the background population, as was done here. Sticking to the smoking and lung cancer example and moving to 1950, at this point we typically saw ecological evidence here, a sharp increase in lung cancer incidence correlated to a sharp increase in the amount of individuals that were smoking. And this type of association with no individual level comparison was sort of the best that we could do, but we then sort of moved to the case control thinking here in the seminal paper by Doll and Hill, where we had distributions of smoking patterns, so the amount of cigarettes smoked among cancer patients and patients without lung cancer. And this created a distribution that could be compared to one another and statistically, and to identify the fact that smoking was in fact more common among lung cancer patients than those without lung cancer, hinting at an association between smoking and lung cancer. So this sort of study design, the case control study design, is of course contrasted to the cohort study. Whereas we in the cohort study follow a group of individuals using a drug under scrutiny and a group of users using another drug and follow them over time. In the case control study, we identify the individuals with the outcome and we identify their drug use pattern and compare it to the drug use pattern in the background population, that is among individuals without the event. We have already covered this example where we look at a cohort study, 10,000 people, girls using all contraceptives followed for 3 years, and we see 200 outcomes. In another cohort, we have 20,000 girls not using all contraceptives, and we see 100 outcomes. And from the follow-up, we identify the number of events and follow-up incidence rates in the two groups and compare them to incidence rate ratios. The case control version of the same thing would identify those with the outcome, those without the outcome, or individuals sampled from the underlying cohort, which I'll get back to in a little while, to see what the drug use patterns look like, and from that we can estimate an odds ratio associating the exposure, here oral contraceptives, to the outcome, here deep vein thrombosis. Before going to the technical details, one might ask why. And I'll give you an example to qualify why this is sometimes very meaningful. There is an established by now association between appetite suppressant drugs and primary pulmonary hypertension. there is a very strong association. In fact, it's about a 20-fold increased risk. But the baseline risk of this very rare disease is, of course, very low, in the order of 2 per 1 million person years. And just to illustrate how rare this is, if you considered all Danes using this drugs, we would see from 1 million people, we are 6 million Danes. That would correspond to the 2 billion multiplied by 6, that is 12. And with the relative risk of 20, the baseline risk of 12 events would be multiplied into 240 events. So we would basically only see 240 events if everyone used the drug. But in the more realistic scenario of only, let's say, 100,000 users of this drug, we are now talking in the order of 4 outcome events instead. And this difference is important because typically we see very small numbers, and in that case we would probably like to identify the cases and validate these cases and only follow these 4 individuals and some controls and look into their, for instance, medical records, compared to monitoring every Dane across the entire country, as would happen in a corresponding cohort study. So for very rare outcomes, there is a reason for using the case control study on occasion. Another example of a situation where it's necessary to use the case control study is when we want to run very many different analyses of different exposures for a common set of outcomes. In this study, we looked at any exposure, whether that was correlated to cancer outcomes, and we did that across 99 different cancer outcomes. This corresponds to thousands of studies because for each of these 99 cancer outcomes, we had to run a different study per drug class and individual drug available in Denmark. This would not have been feasible using a cohort approach, where we would have had to resample the cohorts and the comparison for each drug. We would have to resample all these different cohorts of users and non-users. But the case control study lends itself quite easily to this because we can sample a specific set of cases and controls and then look at their exposure patterns back in time, making it much easier and much more computationally efficient to look at these very large number of outcomes and exposures. So in this particular case, we ended up with a list of more than 1,000 associations that would not have been feasible in other metrics. So the core idea is reasonably straightforward. Look at exposure patterns among those with disease and without disease, but the devil's in the detail. First, we need to discuss the concept of the source population, and this is typically denoted as the population from which cases and controls are drawn, that is, sampled. And I will typically avoid this population thinking because the population is typically less well defined, and rather go for the cohort from which cases and controls are sampled. Because we should always, in a modern day case control study, be able to identify the underlying cohort in question. So consider this cohort study. We have a lot of individuals followed for a lot of time, and some of these have an outcome. And in this figure, I've noted sort of with bold lines that we are in a cohort design utilizing all available follow-up. However, in the case control design, the starting point is only considering the outcome, here denoted as the red bullets or red dots. And we will then also sample some person time, denoted by the green dots. And we're doing this from the underlying cohort. So in a modern day case control study, you should be able to sort of envision the underlying cohort, but instead of using all the available follow-up, you're only taking these samples, specifically the samples including all the outcomes, and random samples from the underlying cohort. And you'll toss the rest. And that's quite important because I am not saying that you should divide your cohort into those with outcome and without outcome. That will in fact bias your results. It's a matter of the person time with the outcome and a random sample of the exposure patterns or the person time from the underlying cohort. That means that you can, at a later point, have an outcome and still be included as a control. So for instance, if a case control study samples cases and controls from 2000 until 2020, if someone is sampled as a control in 2005, but gets the outcome in 2012, this person should already or still be included as a control in 2005, despite later having the outcome in question. Has it always been like that? No, it has not. Historically, there's been other ways of doing case control studies, which is part of the explanation why case control studies are sometimes described as being a less robust study design than, for instance, a cohort study. A traditional or case, non-case or cumulative case control study would see this division of everyone into whether they got or did not get an outcome at the end of the study period. So basically taking this underlying cohort and splitting it into those with outcome and those that never experienced an outcome, and then looking into case and control from that. But that's not how you should do a modern day case control study. Here you should sample the controls from the underlying cohort instead. An example of a unfortunately incorrectly described or incorrectly designed case control study, but fairly recent one, a study that is associating drug X and the risk of Y in this particular database from 2002 to 2013, defining cases as those that underwent surgery in this period, and controls were patients with no history of surgery between this or treatment of this outcome disease Y in the full study period. And while this might seem like a case control study, it really isn't. Instead, control patients should have been sampled for the outcome patients or the case patients with no sort of consideration as to whether they would later get an outcome event. So back to the case control design, you have an underlying cohort, you have the outcomes, and you have the random sample of the background population as your controls. One example to illustrate the sort of nitty-gritties of the case control study design. This is an example of the exposure of lithium and long-term use of lithium and risk of colorectal adenocarcinoma. So lithium is a drug used mainly within bipolar disease and to some extent also in augmentation of severe depression. But for all practical purposes, this is a matter of bipolar disorder. And we have here a selection of cases. So first, within the study period of 2000 to 2012, we identify everyone with an colorectal cancer. That is the outcome questions. And then we restrict this to those in the underlying cohort that we would like to follow. We get rid of those without histological verification, so unconfirmed outcomes. We restrict to those within 18 to 85 years. We restrict to those without a previous cancer prior to this outcome event. We restrict to those without specific diseases that are specific risk factors. And we restrict to those that had resided in Denmark for 10 years up to their outcome event. And this corresponds to a cohort in which we follow all adult Danes from turning 18 until turning 85, after which they are censored upon having a cancer outside of colorectal cancer, censored upon seeing a diagnosis of IBD, for instance, or other sort of exclusion criteria here, and censored upon migration. So basically this is describing the flow of cases, but should translate into the inclusion and exclusion criteria of the underlying cohort. And once we have these finally 36,000 cancer events, we will then identify individuals from the background population that meets the same criteria, that is, comes from the same underlying cohort, that are matched to these cases as controls. And again, this describes the underlying cohort more so than the flow of case patients. Once we have these individuals, we are looking into their drug use pattern. So we now have a group of people with colorectal cancer and a larger group of people without colorectal cancer. And for all these individuals, we, at the time of sampling, be it a random sample for the controls or a specific index date for the cases, we divide them into whether they are non-users or ever users of lithium, and among ever users, the specific predefined main exposure criteria of long-term use. So cases and controls, there's 36,000 of them having not filled lithium prescriptions, and let's focus on the cases. 159 of them have filled one, and about half of those have used lithium for more than 5 years. This allows us to estimate measures of association, in this case for a case control study, and odds ratio. And here we have the crude odds ratio, which denotes as sex and age adjustment, because we've matched these cases and controls on age and sex and performed conditional logistic regression, and an adjusted odds ratio where we include more confounding variables that we have measured, such as smoking and psychiatric diagnosis, etc. And here you see there's absolutely no increased risk, at least nothing that achieves statistical significance. We can also, in this context, because it's very easy to do in a case control study, instead of looking at just ever use or long-term use, have subdivided the amount of years spent using lithium into strata here from 1 year up to more than 10 years, and perform a similar subdivision. So this is basically 159 cases subdivided into 4 strata of use to perform dose response analysis here. And this is one of the pros of using case control studies, in that it's very easy to perform additional analysis of, for instance, different exposure metrics. But there are, of course, also cons to this. So, as mentioned, one of the pros is that it is statistically highly efficient. It is typically less resource demanding, and it's very easy to look at multiple exposures at the same time or in the same study, because changing your exposure doesn't change your framing or your sampling of individuals. It's just a matter of measuring something differently. In a modern day setting, the less resource demanding the computational efficiency is typically less of an issue, since we now have very strong IT equipment that allows us to brute force our way through even very complicated and time-consuming analysis. So this is today less of a benefit to the case control study. There are certainly also cons. First off, at least in principle, this only provides relative estimates. There are ways to estimate absolute risk sizes or absolute effects sizes in a case control setting, but it is much more complicated. And whenever we would like to see absolute risks, one would typically use a cohort study design. It's also not suited for multiple different outcomes. I can easily, in a case control study, subdivide an overarching outcome into subtypes, but if you want to change the outcome, you are certainly changing your sampling frame and will have to basically redo the entire study. So while it's easy to change your exposure, it's not as easy to change your outcome. It's also less efficient with rare exposures, since we can, with rare outcomes, look only at this sort of subgroup that have the outcome. That makes sense, but if it's a very rare exposure, we should rather include on the exposure instead to optimize the statistical precision. And finally, the control selection might go wrong. I've described it very sort of overall, in that the control should represent the underlying study population, the underlying cohort, but we see very many studies where this selection of controls have been through one bias mechanism or the other, ends up leading to spurious results. And then there is an additional con that is a little sort of more meta to this, in this design is very often misunderstood. And as an example of often misunderstood, this is from a paper, seeing it rejected, where the committee of evaluators, the editorial board, felt the case control study methodology is intrinsically weak. And there are very many different reasons for this type of misunderstanding. Also historical in nature. As mentioned, some of the earliest case control designs did not follow the modern approach to this. But also that an average reader is typically used to reading a table 1 where you see the exposure characteristics or characteristics of individuals in your study, and they would like to assess they are balanced. But in a case control study, we are not really describing the comparison in the table 1, we are describing cases and controls. And you will in many cases, for instance this one where we've looked at cases being people with a brain hemorrhage, see that exposure patterns such as vitamin K antagonists or low dose aspirin is much more common among the cases than the controls. And this, for some clinical readers, might suggest this is not a reasonable comparison to make, when in fact all risk factors should be more prevalent among cases. In this case, we should expect to see drugs causing a brain hemorrhage to be more prevalent among those experiencing the outcome compared to the background population. But this is one of the many ways where it is a bit complicated to convey your message in a case-controlled study. So when should you consider using this design? If you want to use very many different exposure definitions, either different drug exposures but also subdividing exposures, it is typically easier in a case-controlled study. If the outcome is very rare, in particular if you are to identify all outcomes in a given study, then this sort of restriction, identify and, for instance, go through medical records or other sort of qualification of your outcomes, then it's probably easier to do in a case-control study, where you can then look into a smaller set of individuals instead of looking into the defining characteristics of every user of a drug, which might only yield you a very small proportion of those users that ultimately contribute to the statistical sort of certainty of your study. In the case where you have computer power as a limitation, of course, as well. There are situations where it's probably best to avoid if you're studying multiple outcomes, if the exposure is the statistical bottleneck, and when absolute risks are central. And also if you are doing active comparators, that is, instead of comparing drug A to non-use, you're comparing drug A to drug B, we would typically also use a cohort study design. And generally speaking, I think in modern day pharmacoepidemiology, the easiest recommendation would be that unless there are things that argue in favor of you going for a case-controlled study, something that is a specific reason for why a case-controlled study might be preferred, then the basic recommendation is probably to go with a cohort study.